Today's lesson objective is A.6C. Investigate, describe, and predict the effects of changes in m and b on the graph of y equals mx plus b. Before we get into some examples, I want to first make sure we have good understanding of what the m and b represent. To start with, we're referring to what's called a linear function. The parent function of a linear function is simply y equals x. Now remember, a parent function is the most basic form of the function that provides you with the shape of graph you're desiring. So in this case, we're desiring a straight line, so y equals x will give us that straight line. Now, what we can do to alter that linear graph is by altering the m and the b in y equals mx plus b. Right, this is often referred to as the slope-intercept form. Again, that's y equals mx plus b. Now, the m in y equals mx plus b stands for slope, or sometimes referred to as the rate of change of the graph. And the b, well, the b stands for the y-intercept, basically where the y-axis is crossed. Okay, and the important thing to know about the y-intercept is the x value will always be 0 no matter what the y value is. Okay. Now, basically what we're saying here is that all graphs can start from the original parent function y equals x. All right. For this one, for the y equals x, we would say that the slope, our m value, is going to equal 1 over 1. Okay. And you know that because there's the coefficient for x there is 1 when it's not written. And our b value is equal to 0. Meaning our y-intercept here is going to be 0 for this parent function here, y equals x. So if I were to go to graph that, just make a quick basic graph. Basically saying that if you start here at the origin, because the y-intercept being 0, meaning it's going to start here at the origin. All right, and let's draw a few marks here. Okay, so if we start here at the origin, since our y-intercept is 0, our slope is 1 over 1, meaning that it's going to rise 1 every time it runs to the right 1. So if we go right 1, it goes up 1. Again, if it goes right 1, it goes up 1. A few points here so we can kind of see it. All right, and so our line goes something like that. So all linear functions start here, and then everything else is some alteration of this graph. So again, if we change the coefficient of x, we're changing the rate of change, so how quickly it rises versus running. So in other words, here we're rising 1, running 1, but if I make my slope 2, then the fraction will be 2 over 1, so that means every time it runs 1, it rises 2. Okay, if I make my slope negative, then such as -3, then we're saying every time it runs 1, it goes down 3. Okay, so you can change your slope by changing the coefficient here, x. And then by changing the b value, we're changing where the graph crosses the y-axis. So basically, we're causing the graph to translate up or down along the y-axis, whatever that value is. So if it's +4, we're going to translate the graph up 4 units, and it would cross here at y equals 4. If we make b -2, then it's going to translate down 2 units, and it will cross down here. Okay, so changing m and b alters our graph by either changing the rate of change or changing where it crosses the y-axis. So now let's get into some examples. Here it says the graph of a function is shown below. So we have this graph here. It says if the slope of the line is multiplied by 1/2 and the y-intercept is decreased by 2, what will be the equation of our new line? All right, well, first let's start by identifying the equation for the line that's being provided here. Okay, so we're looking for two things, right? We're looking for the slope, and we're looking for the y-intercept. Once we have that, then we can write it in the form y equals mx plus b. Alright, so the y-intercept is pretty easy to spot. You're just looking for where does it cross the y-axis, right? And so here we're crossing at the value of 3. So we have a b value of 3. Now to get our rise over run or rate of change, you're going to locate 2 points that can be easily read on this graph. So when I kind of look at this graph, I think the y-intercept is a good spot to start, and I think this one right here is another good place we can read. Okay, and if you don't choose those two, if you choose two others on the graph, that's fine. Whenever you write the ratio in simplest form, you get the same value no matter what 2 points you pick on the graph. So here we need a rise over run, or what sometimes is called change in y over change in x. The little triangle symbol just means change. Now the easiest way to spot that is to count how far up you have to go, or down, depending on which direction the line's heading, and how far to the right you have to go to get to your points that you selected. So this one has a rise of 1, so it goes up by 1, and a run of 2. You do want to check the scaling on your graph, make sure they don't try to trick you. Sometimes they'll, instead of counting each tick mark by 1, they may change it by counting by 2s or 5s or something. So be watchful of that. But here, these are counted by 1. So this has a slope of 1/2. So my equation for this one would simply be y equals 1/2 x plus 3. Now, if we do what it talks about, it says the slope of the line is multiplied by 1/2. So we're going to multiply our 1/2 slope by 1/2, and our y-intercept is decreased by 2. So we're going to subtract 2 from our y-intercept to get our new equation. So off to the side here, I'm going to see what 1/2 times 1/2 makes. In other words, what is 1/2 of 1/2? Half of 1/2 would just be 1/4. Right? Half of 0.50 is 0.25. You think of it that way. So my new slope is going to equal 1/4. Now my y-intercept needs to be decreased by 2. Well, it was 3, so 3 subtract 2 means our new y-intercept is at 1. Okay, so this is our new m up here. This is our new b right here. So my new equation for my line is going to be y equals 1/4 m. I'm sorry, 1/4 x. M is the 1/4. Plus 1. Okay, so now it's a sketch and label that new line on the graph above. So when graphing slope-intercept form, always start with the y-intercept first. So this thing has a y-intercept of 1, so we're going to put a dot right here where the y is 1. And it has a slope of 1/4, meaning that every time it runs 4, it rises 1. So we're going to run 1, 2, 3, 4, and we're going to rise 1. And it may help to make just a couple of points on the graph. 1, 2, 3, 4, over, up 1. Just so you can kind of see where it goes. If you need to work it backwards, just do the opposite. Go down 1 and go left 4. That helps you to see which direction to go this way. Okay? And then, of course, you want to use a ruler to try to make this line as straight as possible to make your graph. Okay? All right, let's look at another example. Here we've got the graph of the function shown below, y equals negative 2x plus 3. The new line is created by multiplying, again we're multiplying the slope of the line shown above by 2. Okay, so we're multiplying the slope by 2. And we're going to add 2 to the y-intercept. Will be the equation of our new line, and we want to sketch and label it. So here we've kind of been helped out. We've already been given the equation of the original line. So we just need to identify what our m and b are for this equation. And since it's y equals mx plus b, the m is always the coefficient of x, we're going to know that the m here is this negative 2. So we're going to put negative 2 for the m because it's the coefficient of x. And our y-intercept is the constant being added, so our y-intercept here is 3. Okay, so now let's do the changes it wants us to do. So we want to multiply the slope by 2. So we're going to take negative 2 and multiply that by a value of 2. Negative times positive is negative, and 2 times 2 is 4. So our new slope, or for our new equation, is going to be negative 4. And then he wants to add 2 to the y-intercept. Well, the y-intercept was 3. So if we add 2 to that, we get our new y-intercept of 5. Okay, so we're ready to write our new equation. Y equals our slope of negative 4 times x plus our new y-intercept of 5. Okay, so from there we can graph our new equation, and starting with the y-intercept here at 5, and using our slope of negative 4. If we make that into a fraction, it's going to be negative 4 over 1, meaning that the graph's going to go down 4 every time it goes over 1. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Let me do one more just in case, just so I can get a real good picture where the line goes. And once I know that, I try to use my straight edge again to try to follow my points. Create my new line. Alright, just a couple more examples here. So this one says, what will happen to the slope of the line graphed below if the x-intercept, ooh, look at that, x-intercept, not y-intercept. X-intercept is increased by 3, and the y-intercept is going to remain the same. So first let's start by just graphing what the new graph's going to look like. So here, right now, the y-intercept's at 2. That's supposed to stay the same. We don't want to change that. But the x-intercept should increase by 3. Well, right now it's at negative 3. Well, it's at negative 3, and we want to increase that by 3, meaning add 3 to it, right? It's going to go up to 0. Negative 3 plus 3 is equal to 0. So my new x-intercept will be here. But they didn't want the y-intercept to change. They wanted it to remain the same. It was at 2. So that's supposed to stay there. So the new line, interestingly enough, just became what? That's right, it just became the y-axis. And now it's no longer actually a function. It actually breaks the rules of linear functions. You can't have a linear function that's a vertical line. So what happened to the graph? Well, it just became a vertical line, making it no longer a linear function by making our x-intercept go up 3 and leaving our y-intercept the same. Alright, finally, let's look at this one. If the function y equals 1/2 x plus 1 was changed to y equals 3x plus 1, what was the effect on the graph of the function? So look at what's changed here. You had an m that was 1/2, it's now 3. You had a y-intercept that was 1, it's still 1. It didn't change. So when we look at that on the graph, for the first one, again, y-intercept was 1. As a rise over run of 1/2, so I mean it goes up 1 over 2 each time. So up 1 over 2, up 1 over 2. So kind of get an idea where this graph goes. Right, whereas the other one also has a y-intercept of 1, but it's supposed to go up 3, then right 1, because it has a slope of 3 over 1. Up 3, right 1. So interestingly, sorry, that's not very straight. Again, using your straight edge to draw these makes a big difference. But you can still tell pretty obviously that the slope is much steeper for the line y equals 3x plus 1 than it is for the one y equals 1/2 x plus 1. Okay, so you have a much steeper graph, meaning that it's rising much quicker as it runs over 1 each time. Okay, well this concludes our discussion of the effects of changing the slope and the y-intercept of your equation and how it affects your graphs. Thank you.